I was thinking of glamoring it up with a nice name, but as you can see, my creativity just lasted only this much. So what you get is encryption and security and in cloud. Okay. All right. I have some more, surprises rolled into my presentation, and I would want you to be patient with me when that phase comes, right? But for now, just to set some context, I want to talk about security off cloud first, and then we'll go into security in cloud, right? For your applications, for your workloads, and things like that. Okay, but it's not a trivial thing for sure, especially the amount of data that is now getting moved to cloud. Security is becoming more and more important, right? So it has to be very sophisticated. And you don't do it by, it's not like a big lock that you put on your front door and you think everything is, okay. It has to be layered, right? So security has to be baked in literally every layer of your architecture. And if you look at a typical stack in cloud, right, which begins with users, something that probably, people who interact with your application or systems that interact with your application, all the way down to the hardware on which your code is finally getting executed, right? But when it comes to security, you essentially have various degrees of responsibilities as a consumer of cloud, right, that you need to consider. So for example, if you choose to run your application in your own data centers, right from the security guard who stands at the entrance of your data center, all the way to the crypto library that you use in your application, it's your responsibility, right? And that's why everything, when you choose to run on-prem, is your responsibility. But as you start to leverage cloud, certain portions of security responsibilities get shifted to the technology provider. But at any point in time, this doesn't happen that you have no responsibility at all, right? Security will always remain, concern for you as a developer, and that's why it is important to, kind of internalize that and keep that in mind. Okay. Now, when you come to Google Cloud in specific, right, what I just spoke about was general. When you choose to move to cloud versus when you choose to run applications completely on your own, what is the security posturing and what is security responsibilities and things like that. But when you move to cloud, don't bother reading the slide. Nothing is important. It's just that there are a lot of things that you have, right, at your disposal that you can use in order to make sure that you are baking in the good security principles and practices into your application to make it secure, right? But an easy way to see this would be probably this slide. A large portion of security is completely abstracted away, especially at an infrastructure level, right? So from operating system and below, probably you don't have to worry about security at all in Google Cloud because it is something which is taken care of by us, okay? But for the layers above, you get tools and technologies and APIs and constructs and architecture patterns, as well as a broad ecosystem of partners who have built technology specifically for security. That is also available for you as application developers and architects to consume in order to ensure that your data remains secure, your application remains secure. Because you see, what happens is security is like buying insurance. Okay, all that effort that you put in writing extra code to make things. How many of you just test on HTTP, right? Don't even bother HTTPS while you are developing, right? Because you think of it as an overhead, right? Who would go do all that extra work of setting up HTTPS and doing all of that long live HTTP? But when you push your code finally to production, you know that you have to factor for HTTPS, right? I mean, that's just one very small example of how we treat security as an overhead or as a burden rather than part of your application development process itself. And that can have a long-bearing effect because once you become, your application becomes popular, right, and you hit a security breach, that one really nifty feature in which you put all your efforts to, in order to build it is not going to save you because your users are going to ditch you because they believe your application is not secure, right? So, you really need insurance when you really need it. Security is exactly like that, right? But that does not mean that the efforts that are needed in order to build a good, secure application has to be, super complex, or it has to be, too much of an overhead. There are ways to make it simple. But here is the contention, okay? When I was building this talk, I was thinking I'm going to talk a lot about security, but there are certain foundational concepts, like the building blocks, that if you don't get it, probably rest of the construct in security you would not be able to appreciate it truly, right? And in order to do that, we have to deal with maths. So how many of you are open to seeing some maths? Can I have a body poll? Wow. First of all, you raised your hand after lunch. I'm happy, right? And that to so many of you, I'm really, really pleased, right? So, what I'm going to talk about is, security from grounds up, right? So we'll look at how encryption algorithms work. Again, this is not going to be a full talk on how algorithms work. This is just to kind of set certain, ground rules of how encryption works in general, and then how that fundamental concept of encryption is leveraged in cloud as a whole is what we will explore, right? Now, this is a very common, we just wanted to put some context here, right? You have two ways of doing, any sort of encryption. So for example, one could be symmetric, asymmetric. I'm sure most of you know, but our focus is going to be on the asymmetric part, okay? This is what we'll talk about because this is what is used mostly in all, security related practices as well products that you would see on cloud, okay? Now, how asymmetric encryption works is, the concept behind it is actually very simple. It is modular arithmetic, right? And how many of you know modular arithmetic already? Like at the back of your hand? Okay, good portion, but probably 50%, right? So I'll just take a minute to explain this. Think, the best way to imagine this is with a clock face, right? I tell you at 9 o'clock, I'll meet you after 4 hours. At what time am I going to meet you? 1 o'clock, right? That's modular arithmetic, right? So if I do 9 mod 4, I get 1, okay? And that's, that's the logic. So now imagine you could basically get 1 as an answer for a for an infinitely large set of initial number, right? So I could possibly, think of many numbers which when divided by 4 gives remainder 1, correct? So if all what you knew was 1, there is no way for you to tell me whether it was 9 or whether it was, 17 or what was the initial number, right? Now this is a very useful mathematical phenomena that comes in very handy in case of encryption, right? So now that we have understood modular arithmetic, we'll look a little bit into what role prime numbers play in encryption. Now, again, I'll do a body poll and tell me how many of you are interested in knowing the whole prime number, role of prime numbers in encryption. Wow, okay, all of you, which is good. I would have responded differently, but you have asked for it, so you are now emotionally invested. Okay, so we choose two numbers. In this case, I have 5 and 14, and I'll tell you from where these numbers come. But for now, just suppose I have two numbers, 5 and 14. And I have a payload that needs to be encrypted. So in this case, I have taken letter B, and I'm representing letter B with number 2. Right? So A is 1, B is 2, C is 3, D is 4, and things like that. Okay? Now this I want to basically encrypt and then send it to whosoever the receiver is. So what I do is I create what is called as the encrypted ciphertext. And how do I do that? I take this payload, which is 2, and I raise it to this prime number that I had selected from my key pair. Okay? So now 2 to the power 5, okay, is one number that I would get, and then I would do a modular arithmetic with the second number in my key pair, okay, which is 14 in this case. So what's that calculation? 2 to the power 5 is 32. 32, you divide by, do a modulo arithmetic 14. What is the remainder that you get? You get 4, right? And this is the encrypted ciphertext. So now my B gets converted to D, right? 2 gets converted to 4, and I send D, okay? Now the guy on the other hand who receives it, this whole encryption, this is the encryption cycle. The guy who receives D at the other end, what he is going to do is, he has his own set of, he or she has, another set of 2 numbers, okay? Now in this case, you would see there is one number which is common, which is 14, okay? And I'll tell you later why it is 14, right, or not any other number. But he has another number which is another prime number, and this prime number is not known to the other person, the person who actually sent this ciphertext, okay? Now, what you do is you take the ciphertext and do exactly the same thing. You decrypt this text by taking your ciphertext, raising it to the power of the prime number that is known only to you, and then doing a modulo arithmetic with the pre-agreed common number. So in this case, 4 to the power 11, I'm pretty sure, don't try to do it. It's a very large number, but trust me on this, when you do a modulo arithmetic of that, what you get back is 2, right, which is B. So I took B, I converted it through some mathematical magic, I converted it to D. I sent that D to someone else, and what I got back was D again, right? Now, as you would have already guessed in this particular case, right, we have 2 numbers that we are dealing with, and some guy has a private number, and then there is this pre-exchanged common number, right? These are nothing but your key pairs, right? Something that all of us are very familiar, at least conceptually, right? All of you have already used your private keys and public keys, right? Now, this is just an illustration to show the mathematics behind how these, these keys play an important role. Now, I could go at further depth and show you some more maths on how do you determine these keys. And this is, again, something that you need to tell me if you're interested or not. Do you really want to know how these 2 keys get decided? Okay, raise your hands. How many? Okay. All right. So here you go. You're asking for it. So I picked 2 prime numbers, 2 large prime numbers. Okay. Now I have intentionally picked 5 and 7 because these are probably the only numbers with which the whole explanation works fine, and the calculations don't go offhand, right? But I picked 2 numbers, P and Q. So these are 2 prime numbers, 5 and 7, and I multiply them both. I get 14. Now when I get 14, and I give you 14, you can't really, of course 14 is a small number, so you can easily tell me its prime factors. So you can say that it is 5 and 7. These are the 2 prime numbers. When multiplied gives me 14. But you could also get 14 by 7 and multiplying 7 with 2, right? Okay. The problem is when the numbers are really, really big, okay, it is going to take many, many years, even with advanced computers, for you to arrive at what were the 2 prime factors. Now, one important thing that I missed explaining here, that the number that you get, right, has to be of a desired size. When you multiply these 2 prime numbers together, right, you get, the key size, when I say 256, bytes or 128 or 1024, this is essentially the total length of the final multiplied number that I would get, okay? Now what I do is, I find a function, okay? This particular function creates a list of those numbers that are co-prime with my selected number n. Okay? Now, what are co-primes? Co-primes are essentially those numbers that don't really share, prime numbers with each other, number theory, blah, blah, blah. So in this particular set, I have 6 co-primes, right? Now, there are certain rules. You can actually very easily find a total number of co-primes for a given number. The formula for that is p minus 1 minus q minus 1. So if I have, my prime numbers are 5 and 7, the total number of co-primes that I would get is actually 5 minus 1 multiplied by 7 minus 1, and that's how I get 14. Okay? That's how I get 6. Okay? Now, the next thing that you have to do is you basically have to choose, a number E, okay? Now this E has to be something which is greater than 1, but it has to be less than the total number of coprimes that you had, what you found earlier, which was phi of n function, right? So in this particular case, the number has to be greater than 1, but less than 6, okay? And E is a coprime of n as well as phi of n. That means it has to be a coprime of 14 as well as coprime of 6, okay? So in this particular case, what number would satisfy that requirement? 5, and n was 14. Similarly, what I do is there is another number. So E is what is used for my encryption, right? E is my encryption key, and D is my decryption key. And this D follows this rule over here that you can see. In this particular case, the number has to be 11, okay? So this is, there is a reason behind how you pick these two numbers, right? And that this is precisely what you use when you generate your key pairs, right? This is the mathematics that is going underneath. Now, once I have arrived at key pair, of course, the other problem is that you would want to exchange this key, right? Because there is some information that has to be shared between two parties before this encryption flow can take place. And there again, we have key exchange algorithms that take care of, how to do that. Now, this part of math, again, if you're interested, this is how it happens. I pick a large prime number A. The person who I need to exchange my information with picks another large prime number, right? Then there is, based on the algorithm, there are some pre-agreed, there is a small prime number, and then there is another large prime number. You do some modulo arithmetic, you exchange information, but at the end of it, what you essentially get, that people, those two parties who need to exchange information with each other, they get the same number, but anyone who was listening in, okay, they don't get exactly that number, because G, anything that is raised to the power, AB, is different from anything that is raised to the power A plus B, right? So essentially, this is a very secure way of using a unencrypted channel, an insecure channel, to communicate something that is, that is a secret. So now what happens is, I can now safely exchange keys. But you would have seen in this entire conversation, right, there is so much of focus on keys, right? How do you manage these keys? That is the crux of the security practice in cloud, right? Because the whole encryption part is already taken care of. You pick up your favorite crypto library, it will take care of how to manage encryption for you, it will take care of, it will give you the necessary APIs in order to carry these tasks, right? And depending on where in the stack you are, there are libraries that are hardware optimized that can do wire speed encryption, decryption for you, right? So all of that is, the infrastructure for that is very good, but it expects you to do one thing, which is manage your keys properly, correct? Because anyone who has your encryption keys, if I knew that prime number that you selected, right, it's as good as not having encryption at all, right? And that's when, all the bad things start to happen. That's why if you look at Google Cloud, right, we have taken encryption, very seriously. There are very few ways in which you can actually store unencrypted data in cloud, in Google Cloud especially, right? So all the connections are automatically, most of the network connections that you would see, they use, network encryption. So data while in transit is always encrypted, right? That way, the data in transit is always secure. Moreover, when the data finally lands on storage, right, there again it is encrypted and stored, right? So from a storage standpoint, you are always protected because there is encryption, right? But then there is another concern, right? The best kind of security is a security where you trust no one, right? You do have a big lock at your front door, but then you lock your, the place where you keep your jewelry and other expensive stuff as well, right? And there is a reason for that, right? There are different degrees of trust that you have right? In our normal lives as well. And it is important that you factor for that, right? In many cases, you would trust Google 100% with that, they are doing a good job, they can keep my data secure, right? And I will let them manage the necessary keys that have been used in order to encrypt my data. But there are certain scenarios and certain very real requirements where you would say, hey, I want my data to be completely controlled, right, by me. Even Google should not have access to it. No one should have access to it. And there are many use cases where the industry dictates that you need to have certain requirements in place, right? So for example, you look at a bank, or you look at probably some healthcare services and things like that, where you are mandated by law to follow certain security practices that requires some degree of autonomy that needs to come in ways your keys are managed, right? So in Google Cloud, we have basically created infrastructure that takes care of the entire spectrum of key management, right? So there is at one end where everything is really transparent. It's default encryption. You store your data, it is always encrypted, right? But on the other end of the spectrum, at the really far end of the security spectrum, you could actually have mechanisms where Google has no control over how your encryption is done, right? On a side note, if you do choose to build applications which is using a security key management at the last end of this encryption, and you lose your keys, you can kiss goodbye to your data because there's no way to recover it, right? There is no key repair guy that you can call and he can come and fix it. Okay? So you have to be very, very careful with the way you manage your keys. And trust me, it has happened, right? In my experience, it has happened. A really important database, it's encrypted, the key gets lost, and that is it. Okay? You don't want that to happen to you. Okay? But so how does this work? The core of key management is, barring the obvious one where you essentially have default key management, is a key management system, KMS. And if you would have seen in your Cloud Console, you see a functionality which is Cloud KMS. Now, Cloud KMS is that stack that gives you a mechanism to manage these keys, right? Now, key management, it's not only about storing it once. Think about it, right? You have data that is always growing, right? It keeps coming. You keep getting new set of data. And you are storing it in one location. Imagine if you have encrypted all your data with just one key. What happens when that key gets compromised? All your key is gone? All your data is gone? But what if I have a practice which says, hey, you know what? Every week I'm going to generate a new key and I'm going to encrypt my data with that new key. Now, if one of my keys get compromised, what happens? I have lost only 1 week worth of data, correct? Now, which is a better option? Lose all your data or lose just 1 week of data, if at all you have to lose? The 1 week one is a more obvious one, right? So what you would do, you would want to more frequently keep generating new keys and keep, keep rotating your keys, right? Keep making new versions of the keys and use that key in order to encrypt your data. But what it means is, when you want to decrypt it, you have to know which key you used, right? To encrypt it at the first place, right? So there are certain management aspects that would come. You'll have to pick which exact key was used in order to encrypt it, so that you can use it to decrypt it. If you are changing your keys weekly, you can imagine how quickly you would have so many versions that you can't manage yourself, right? And that's where the key management systems become important, right? They do this for you, okay, as a managed service. But the thing is, key management system is one part. The other part is, how do you generate these keys to begin with? You saw, right, in the mathematics part that how you select these prime numbers are important, right? And prime numbers, essentially there is a seed function that goes in there, and you know that there is some amount of randomness that is required, right? And if you have any compromised system that is generating these prime numbers, that could possibly become an attack vector itself, you know. So someone who is interested in stealing your keys, if they find it difficult to steal the keys, they could actually compromise your system in such a way that the numbers that are getting generated, they know this well in advance, okay? So that is why, you know, in order to generate keys itself, you have a different mechanism, and you use a tool for that, which is called HSM, right? And HSMs are basically, they are hardware security devices that generate certified prime numbers, you know, saying that, hey, they have not been altered, you know, you can be sure. And certain regulatory authorities will accept this certificate saying, okay, I trust if the key was generated using this tool, you know, I'm okay with it, okay? So from a security regulation standpoint also, it might be mandated that you use HSM. So in Google Cloud, you have two ways, right, in which you can manage these keys. You have a software way of doing it, right? So you have a software-based software key generation infrastructure, and then you also have a hardware-based, more you know, robust hardware-based key generation infrastructure, right? And then the key management software can basically talk to both based on the nature of the application and the security profile of the application. You could choose whether you generate your keys through HSM or you generate it through the software-based system that we have. Okay? So why Cloud HSM is important? Because there are certain regulations, right? And these, you know, when you use HSM, the keys are generated in accordance to those rules and regulations. And therefore, if your application needs to comply to certain norms, you would be able to do so if your keys are generated using Cloud HSM. Like for example, if you look at Aadhaar, right? You know, nowadays you have digital verification for Aadhaar, right? If you are doing anything with Aadhaar, there is a requirement that you have to encrypt it. If you're storing it, it has to be stored in a certain fashion. And that regulation from UADI insists that the hardware key, you know, the encryption has to be done using a, you know, HSM, okay? So if you're building those applications, you need to have support for those, you know, HSM devices on cloud. And that's the reason why we built that entire infrastructure, right? The second thing, as I said, statement, you know, attestation. You can basically get that this key was not tampered with. It's absolutely okay. All of that would, you know, the Cloud HSM will provide that information to you. And this is something that we announced in last Next. I mean, those of you who build, you know, secure application, you would realize that, you know, the algorithm that you use in order to encrypt it is extremely important. So the HSM services, they need to have, you know, a mean or a mechanism through which they can support those necessary algorithms, right? And here is a list of algorithms that we support in Cloud HSM as well as in the software keys, okay? Now, the thing is, I have generated these keys, but the service that I'm trying to use should also be able to consume these keys, right? Are you with me so far? Okay? I have all this infrastructure to generate keys, manage keys and all that, but if I can't supply my keys, right? That means you are using default encryption. In that case, at the worst case scenario, you are letting Google have access to your information, right? Because somewhere they have access to those keys, right? So in this particular case, what you do is you use a tool called, you know, or rather a feature of various PaaS services called Customer Managed Encryption Keys, okay? CMAC. Now, what is CMAC? CMAC essentially is a service that allows you to, you know, hook your, let's say you want to do something in BigQuery, right? You could tell BigQuery, hey, whatever data that I'm going to store in you, please use this particular key from my key management system, okay? So you are essentially saying that the key management will be done by me, okay? You just use the Cloud KMS in order to manage keys. Don't use the default one. So we support it for Compute Engine, for cloud storage, for Dataproc, for BigQuery. So now imagine if you want to run an application in a virtual machine, right? It is your own application. You want to run it in virtual machine. You have got the persistent storage, right? The PDs that you would have, and the compute engine, which will be, which is where your operating system would be running, which is where your application would be deployed. You can use CMake to encrypt the hardware device itself, right? The storage itself, so that your data is always encrypted and protected. Okay, so that is customer managed encryption keys. This was all in context of how you can use encryption to encrypt your data and protect it from, even if it gets, someone steals it, right? Someone unauthorized, an unauthorized party steals it, you are protected because, they can't do with it. It's all garbled, okay? But there are scenarios where, you may have your own people sabotaging you, right? And you might end up having challenges where your, the sensitive data gets accessed by people who have no business looking into that data, okay? Let me give you an example. Let's say you are collecting Aadhaar number, okay, or credit card number. Okay, very good example. I've got a credit card number. For my application flow, let's say you have a chatbot in which you just need, or you have a service application where you only need the last 4 digits of the credit card number. But a dumb customer like me says, yeah, I'll give you the whole credit card number. Okay? Now what happens? Unintentionally, I have ended up storing a very sensitive information, right? And I could not have built an infrastructure which encrypts it and which kind of, does all the necessary security policies. So tomorrow, that credit card number could be compromised from this system because the support agent suddenly sees, I got the credit card number, man. I'm going to now, buy all sorts of stuff that I wanted to buy, and you will have to pay the bill, okay? So in those scenarios, you don't want your data to be leaked, be it intentional or unintentional. Right? So you need a mechanism through which you can prevent such leaks, okay? And this is what you can achieve through a tool that we have built called data leak prevention API. It's not data loss prevention API, right? DLP for short, okay? Loss or leak we will see in the documentation, okay? But the general sentiment is this, that it helps to make sure that you don't lose your sensitive data to someone else. So here is an example, right? This is my table. This is my database table. I have got the username. I have got certain fields. I have got some transaction value, right? And all of this has been protected using certain policies. I have encrypted it as well. I have got proper IAM practices put in place. But if an authorized user get access to the system, they can essentially see this data, right? DLP prevents such, such leaks, okay? So what it will do is, it will take these sensitive fields, okay? And it will just simply make it meaningless, okay? You can think of it as if it is going to mask that data, okay? So that's when an authorized user also has access to those, object level information, they are not really getting the real information, rather they are getting access to a masked information, right? Now this could be a very critical capability that you may want to build into your application, and the best part is this is available to you as an API, so you don't have to build a massive infrastructure, right? So when you use DLP, it can automatically identify if there are emails or there are social security numbers or there are credit cards, there are phone numbers, right? These are sensitive PIIs. It will automatically detect that, and it will make it unusable, right? Even for a verified user, right? So there are various, built-in classifiers that exist in our DLP API that you can use, straight away. What it means is you don't have to do a lot of development work in order to bake this feature in, right? You can use it just as a normal API, okay? You can also design, if our pre-built APIs classifiers are not enough, you can even build your own custom classifiers and use that in order to prevent leak of your data. Okay? So here is a good example of data masking. I have PII numbers, I've got phone numbers, I've got emails, and I can simply pass this data through DLP, and DLP will return a masked set of data, right? Now, there are various tokenization methods that it supports. The idea behind this is if you have a fairly rich requirement in terms of how you want to gobble up your data, you have some flexibility there, right? And you can configure your API accordingly. Okay. Now, this is something that I really like. It does not work only on, uh, uh, databases or digital files. It'll even work on images. So someone uploads their PAN card, for example, you can make sure that their PAN number is, is basically altered when you finally store it in your system, right? So this way, you can prevent your, users to overexpose themselves by sharing too much data, right? At the same time, say for example, someone uploads their social security number. Instead of just last 4 digit, they upload their entire social security card, right? You don't want that liability on your database, right? You can essentially use DLP in order to prevent those scenarios. Okay? Now, how it works? A very quick view into it. Let's say you've got a client or a script that is going to use DLP, right? You have got your application will essentially stream data, right? It is going to go through the DLP API. The DLP API is going to look into it. It is going to inspect it. It is going to classify it. Then it will do the necessary transformation and send the data back. So it works very transparently. You can treat it like a middleware, right, which sits between, in your data access path and makes the necessary changes when it detects some PIIs that needs to be clarified. Now, this does not work only for, streaming data. You could even build it for your, static stored data. So let's say, for example, you have a GCS bucket in which you are storing images, right? And you want to make sure that you are, preventing any PIIs to be identified in the storage bucket, right? You could use DLP even in that scenario, okay? Moving further ahead, right? Here is a good example or a solution that we have built, which basically talks about how you can create a pipeline in which even before the data finally hits your permanent storage, you have taken care of preventing any leaks. Okay, here is another solution example of using cloud data flow in order to do automatic de-identification on your data. So imagine you have a large Excel sheet that comes up from some CRM application. As part of your flow, they send you an extract. You want to make sure that all the email IDs are de-identified. You can essentially build a pipeline in order to do that. Here is an example of exactly the same thing. I've got a spreadsheet that has got email addresses. I mean, this was a CSV file. It lands on my GCS bucket. Cloud Data Flow runs a job which removes all the IP addresses and email addresses from that particular flow. So it could be very useful even if you're logging, if you've written some logging logic in your application, you should be able to use it there as well. Here is a bunch of stuff that you can, go and refer. I did want to talk a little bit about one more area, which was in the network security, which is called VPC service control. Unfortunately, I've run out of time because I did not think you will have so much of interest in the math part of the things, right? But I just want to leave you with the concept there, which is, which essentially is how do you prevent within, again, in your own organization, you don't want people to have, you are working on project A, someone else is working on project B, right? You don't want your data to be exfiltrated, right? You don't want your data to be moved. Let's say, for example, I gave access to googleapis.com. I whitelisted that for a specific use case, but then using that, someone started copying data from my GCS to their personal Google Drive. Okay? You can prevent such scenarios using VPCSE, right? So, do go check about how VPCSE works, but in general, I have taken these 3 important topics. Key management and how robust it is in Google Cloud, the infrastructure options that are available to you while you are building your application. Second is DLP, and third is VPCSE, right? So with that, I conclude. Thank you so much for being so patient. Really appreciate it.